Hey guys, so we're going to do lesson 5.6 today, and then it's going to be combined with chapter 6 for the quizzes and the tests. Okay, so in this one, we're going to graph again, but they're going to be inequalities, right? So when we do that, there's going to be, a couple of things that are going to be different. First of all, depending on the inequality, we're going to use either a dotted line or a solid line. So for example, if the inequality is less than or greater than, we're going to use a dotted line. And if the inequality is less than or equal to or greater than or equal to, we're going to use a solid line. Then we're going to have to shade the region that makes the inequality true. Okay, so why don't we do first? Okay, so this is x is greater than 2. What we're going to do is we're going to graph x equals 2. We're going to pretend the inequality is an equal sign. So we're going to graph x equals 2. Okay, so we know that is a vertical line that passes through 2. But also, because this is greater than, not greater than or equal to, this is going to be a dotted line. So here we go. Just like this. Okay, so that's still a line, but it's a dotted line. Now, do you see how this line separates this entire region into two? There is the left part and there's the right part. What we're going to do is we're going to pick one of these that satisfies this inequality, and we're going to shade that region. Now, the inequality says we want the x values to be greater than 2. So where are the x values greater than 2? To the left of this line or to the right of this line? Well, it's to the right of this line, so we shade this entire region. And so now the solution isn't just the line, but it's that entire shaded region. Okay, this one, y is less than or equal to 1. We're going to graph y equals -1. And because it's less than or equal to, this is going to be a solid line. Okay, y equals -1 is a horizontal line at -1. And again, that separates the region into two, the upper and the lower parts. And we have to pick and shade the one that makes this true. Because we want the y values that are less than or equal to 1, we're going to shade the bottom. Okay. So next, now, these two had just one variable. Only x in the first one, only y in the second one. So we had either a horizontal or a vertical line. This one here has two variables, a y and an x. So here we're going to get a diagonal line. Now, here we're going to graph y equals x plus 3, right? And this is going to be like your y equals mx plus b. So we go to the y-intercept, which is 3. And then the slope is 1, right? So that means I'm going to go up 1 over 1. And this is going to be a dotted line, right? So I do a dotted line. You can still use a ruler to do dotted lines. Okay, here too we have two regions that this boundary separates this into. This is the first region, this is the second region. We need to figure out which one of these we're going to shade. For that, we're going to go to this inequality. What we're going to do is we're going to draw vertical arrows. And by vertical, I mean either pointing completely up or pointing completely down. So how do we know which one? Well, if it's greater than or equal to, we draw a vertical arrow upwards. If it's less than or equal to, we draw the arrow downwards. This one here is less than or equal to. So from the line, I draw vertical arrows downward. You have to make sure they're vertical. They can't be tilted in any way, completely up or completely down. So here we go. Now we know exactly what region we're going to shade. So we're going to shade this region. Okay? All right. Now for this one, I can't graph this the way it is for part D. I need to first solve it for y. I need to get y alone. So I'm going to do minus x. Y is greater than negative x minus 2. This one also has an x and a y, so it's going to be a diagonal line. I'm going to graph, y equals negative x minus 2. And it's going to be a dotted line. So negative x minus 2 is here. Minus 2 goes there. And then the slope is minus 1. So I go down 1 over 1. So here we go. It's going to be a dotted line like we said. Oops. I curved a little. Let me fix it. See how that works. Okay. Now, this arrow, right? This is greater than. So my arrows are going to be vertically up. So I'm going to go up, 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 up. Okay? And then I shade this way. Okay. All right, next one. Let's solve again for y. So first, I'm going to have to add x. So I'm going to get 2y less than or equal to x plus 4. Now, we're going to divide by 2, divide by 2, divide by 2. So y is less than or equal to half x plus 2. Okay, this time it's going to be a solid line, right? Because it's less than or equal to. All right, so here we go. This is the y-intercept, 2. And my slope is 1 over 2, so I go up 1 over 2. We said solid line. So, less than or equal to goes down. Okay, the arrows are going to go down. Please be careful about those vertical arrows. Don't tilt them in any way. And so now it's very clear that I'm shading the bottom. So I go this way. Okay? All right, let's do the next one. Here, for this next one, look, the y is already alone. But you know what? I like to reverse the direction so that the y comes first. And so that means reversing the inequality. Right? I haven't changed the problem. I just rewrote it so the y came first. Okay, the y-intercept here is negative 1. Slope is 5 over 1. I go up 5 over 1. This is going to be a dotted line. Now, for one like this, we're going to be a little bit more careful, right? Because now this line is so steep, and students often, when they're drawing the arrows, they, I don't know, for some reason, make them like tilted like this, or I don't know. You can still go completely down, okay? Into the ground or up to the sky. So less than, we're shading this way, so I go here. Okay, one more time. Here, we need to solve for y. So first I'm going to subtract 4x. Negative 3y less than or equal to negative 4x plus 12. Now we're going to divide by negative 3. Okay, so now I have y. When I divide by negative 3, because I'm dividing by a negative number, what happens to the sign? It switches. So now I have 4 over 3x minus 4. Okay, y-intercept is at negative 4. I'm going to go up 4 over 3, and this is going to be a solid line. Okay. arrows have to be pointing upward. Don't tilt them. And then I shade the upper region. So that's going to be here. Okay. Okay, next one. Let's subtract 5x. 2y less than or equal to negative 5x plus 10. Divide by 2. Y less than or equal to negative 5 over 2x plus 5. Okay, 5 goes here. Down 5 over 2. Solid line. And arrows have to go down. So we're going to shade this part. Okay. So there we go. All right. So last, let's do a couple of just review. Okay. 3x minus 5 equals 22. What is the value of x? We need to solve for x. So first we're going to add 5. 3x equals 27. Divide by 3, divide by 3. X is 9. So that's B. Okay, this one. F of x is 3x minus 1. What is the value of f of 3b? Right, so let's just recap what we have here. F of x is 3x minus 1. I'm rewriting it. What we want to find is f of 3b. So there were lots of different versions of this on the final when I was grading. I think people either decided not to study that part, or I don't know what happened, or they just forgot it completely. However, let's take a look at what's happening here. We have f of x. We want f of 3b. In going from f of x to f of 3b, what's happening? The x is being replaced by 3b. That means inside the function, each x needs to be replaced by 3b. So here I have 3 times x, but now it's 3b minus 1. 9b minus 1, that's f of 3b. That's it. We don't do anything else. We don't divide by the 3. We don't divide by the b. We don't subtract 3b. This is it. 9b minus 1. Okay, so that's it for today. Next, you're going to do your homework, which is a worksheet. Okay, thank you.